All right, let's go ahead and get started. So what we're going to look at today is how to set up and solve story problems for free body diagrams. So we kind of need to establish how we're going to go about setting these up and what these problems look like and what we're trying to do with them before we can get into using Newton's second law. So Newton's second law is pretty straightforward. We're going to do that. We're going to introduce that next class. So that's going to be on Tuesday for y'all next week, and then after Thanksgiving we'll go through more how to solve these, and I'll show you from there. But I really want to kind of get into how do you set up these problems, what do you do with them, what do they look like. So let's get started here. And here is the problem, and if you have trouble seeing this, I will kind of zoom in a little bit later in on the problem. But I want to make sure to kind of get you kind of the big picture of it. So I'm going to go ahead and solve this on a separate sheet of paper here, just so you can see what it would look like solving it in a notebook. You can solve it in a notebook. If you want to print out the practice 2 and solve it on practice 2, you can do that for sure. That's on Schoology, however you want to go about doing it. So here's the problem. If you push a car, has a mass of 1,050 kilograms with a force of 750 newtons. What is the force of friction acting on the car if it experiences a net force of 67 newtons? So these parts up here are going to describe the steps you're going to do for solving these problems. And this is going to be pretty much exactly the step-by-step we'll use even when we get into Newton's second law problems. That'll have a couple of extra steps, but not significantly more. So the first thing we're going to do is we're going to draw the object. So if you push a car with that mass, so I'm going to draw a car here, and I'm going to give myself plenty of room because I'm going to be drawing forces. So since I'm not exactly sure how many there's going to be and in all the directions, I just like to give myself some space to do that. So draw the object, done. Okay, step 1. All right, step 2, draw all the vertical forces up and down. So what are the forces that we're dealing with? Well, these are the ones we talked about in the notes last time. So applied force. So I'm just going to write A for right now since I don't know what the object is. So applied force, force of gravity, my brain's friction, tension, air resistance. What one am I missing? Gravity, tension, friction, applied, air resistance, and normal force. There we go. So those are the forces that we're dealing with. I need to figure out which of those 6, if any, act up and down. So one of them is very simple, and that is gravity, because gravity always acts vertically and it acts on every single problem that we're going to do. So I'm going to draw an arrow down and I'm going to write FG. Okay, now I need to ask myself, are there any other of these 5 forces, now I got gravity on there, are there any other forces that are going to be acting in this problem? So an applied force is an action by an object on your object you're looking at. Well, there's no other object acting on the car in this part in the Y direction. So no applied. Friction doesn't act in the Y direction. In this case, there's no sliding up and down or attempted up and down motion. There's no tension. There's no ropes acting on the car. There's no air resistance. It's not in free fall. But there is a normal force because that's a support force. So that supports the car against gravity. Okay? Now, so I got that done, drew all the vertical forces. Okay, now I'm going to draw all the horizontal forces. So I'm going to go back through my list. Gravity never acts side to side, so that's out. Applied force, is there something acting on the car from another object? Yes, you are pushing the car. So I'm going to draw an applied force forward, and I'm going to call it F push, since it's you pushing the car. Okay, then I need to act on anything else forward. None of these, there's no ropes, there's no anything else. Backwards, I know there's friction. Okay, so friction is going to act. That's against motion. Friction is always going to be against what the motion or attempted motion is. So this would be F friction. There's no second applied force. Some of these you can have more than one of. Sometimes you'll have like more than one object, so there'll be a gravity on each object. Sometimes you can have like more than one person pushing on something, more than one rope, whatever the case may be. There'll always be only one friction force, friction acting on the whole object. And there's no air resistance. It's not free fall. So those are all the forces. So there we go. We drew all the horizontal forces. All right, 4, draw the direction of the acceleration / net force. If it's unknown, write F net. And I didn't write this here, but it's worth mentioning. If it's 0, just write F net equals 0. So I'm going to do that in a different color, and you certainly don't have to color coordinate things. I think it's easier just to make sense of it all, but that's up to you. So I'm going to draw the direction of the net force. So it gives me a net force of 67. So what direction is it? Well, it's not up and down. And I know it's not up and down because the car isn't going up and down, right? There's no motion change up and down. Remember, net force is what causes a motion change. So to figure out the direction, you just ask yourself, what direction is the motion change? Well, it's not up and down. Cars don't fly up into the air randomly unless they run over some kind of Acme Looney Tunes spring that launches it in the air, which is not in this problem. Although that does sound like a fun problem to do at some point. Anyway, neither here nor there. So now that we have that established, it's not up and down. So it's got to be left or right. So which direction is it? Well, it told me it's a positive 67, or at least it's not negative. So that tells me it's in the forward direction. So I'm going to draw an arrow forward. And I'm going to write F net equals 67. Okay? Done. All right, number 5, write the values, if known, for the forces in your diagram. Solve for the force of gravity, and there's the equation for it. So, normal force, is it telling me what it is in the problem? No, don't know what it is. Okay. Push force, does it tell me what it is in the problem? Yes. You push with a force of 750 newtons. So I'm going to write F push equals 750 newtons. Okay, does it tell me what friction is? No, but it says what is friction, so I'm solving for that. And does it tell me gravity? No. But here's the thing. It is very rare that I would give you the force of gravity, but it is very common that I will give you the mass. And if you know the mass, you can always solve for the force of gravity. So I'm going to do that now. So the force of gravity equation is Fg equals mg. So m is the mass, which in this case is 1,050 kilograms. And g is the acceleration of gravity from last several units that we've done, and that's 9.8. Now notice I did not put a negative 9.8, and here's why. You'll remember, hopefully, from a very long time ago, the first time we introduced gravity, I said the value for g is 9.8, but a, when you plug it in, is negative 9.8. The value for g is positive 9.8 because the value for g is a scalar, not a vector. It just is the value for the rate at which objects accelerate. It's not the direction they accelerate in. Now, they do accelerate down, but because we don't always say down is negative, at least you don't have to, that's why it doesn't have a direction to it. So this is a positive 9.8. We're just plugging in the value for gravity. That's it. Okay, for the acceleration of gravity. So go ahead and solve that. When you do, oh, come on, me, I already solved it. What am I talking about? I already wrote down the answer. There we go. When you solve that out, you get 10,290. So I'm going to write that in for FG now. 10,290. Okay. Now, there's one last force left, the normal force. Now, it doesn't tell me what the normal force is. It doesn't say anything about normal force. There's no equation for normal force, but I know what it is. And the reason I know what it is because there's no net force up and down. The net force I drew is to the right. So that means that the up and down net force has to be 0. If the up and down net force is 0, then the up force has to equal the down in order to keep it balanced. 10,290. There we go. 5 done. So I have a bit of a confession to make. What I just did there with gravity and normal force, I didn't have to do. I did it to show you how you would go about doing it, but I didn't actually have to do it. And the reason I didn't have to do it is because, well, there is no, there's nothing asking about up and down. There's nothing asking about gravity. Nothing's asking about normal. So I wouldn't really need to do it. However, on the 2 problems you're going to try on your own here, you are going to have to do it because they're both vertical motion. So I wanted to show it to you just so you could see it there. All right, last step, number 6, find the net force or find the missing forces. Be sure to include the direction with your answers, either by drawing it in the diagram or by and with positives or negatives. But you can also say left or up or down or however it works for you. So how do we find net force? Well, net force is all the forces added together. So I'm going to write here F net equals F1 plus F2. So whatever we have. Okay, so now that I've got that, now I'm going to go ahead and plug my numbers in here. So my net force was given, it's 67. Okay, my F1 is going to be my first force in that direction, which is the push force, 750, plus my other force, which is friction. Now, you might be saying to yourself, well, if friction's backwards, why don't we make it negative? Well, because this is math. It's not a direction. This is math. I'm adding the friction force. Now, the answer to friction will be negative, but when we're finding the net force, we're always adding all the forces together. So don't subtract it here, or you're going to get yourself a wrong answer sign-wise. So to get friction by itself, I'm going to subtract 750 to both sides. And when I do, I get my force of friction equal to negative 687 newtons. And there you go. Last step, done. So that's how you go about doing these problems. You draw the picture, label the forces, write in what the numbers are, solve for gravity if you need it, set up the net force by adding the forces together. And if you know the net force, then you solve for F1 or F2 or F3 or F4, depending on how many forces there are. And if you're solving for net force, then you would just add the forces together to get the net force. Keep in mind, you can only add X direction forces together or Y direction. You can't add the X and the Y together. And so that's why I ignored these 2 forces here. Okay, anyone got any questions for me?
Yeah, I do.
Yeah.
So Natalie's been sitting in the waiting room. She needs to be let in.
It does not say that I have anyone. Let me try to refresh maybe.
Yeah, she said she's been sitting there since 10:13.
Gotcha. Yeah, I don't know. Okay, I refreshed it and for some reason it's showing them now. I don't know why it wasn't before, but I'll let them in now.
All right.
For those of you coming in, sorry I wasn't able to let you in earlier. For some reason, it wasn't showing up that anyone was in the waiting room. So if you want to, here I have an image of the